Welcome to the third video in this series of videos that walks you through how to use your Raspberry Pi to interface with the outside world. This video will focus on programming our Raspberry Pi to receive an input signal through the GPIO to trigger our code on the Raspberry Pi. In this case, it's through a button on our breadboard. This final step can create the building blocks for many different projects and ideas, allowing you to harness the true power of the Raspberry Pi. This part builds on part 2. The circuit will remain similar, and the code will also be very similar. We need a few new components for this project. A button. We want the two close pins, that's our positive and negative. To accommodate our button, we need to make some space on our breadboard, so we're going to change the wiring just slightly. First, we're going to remove our jumper cable. Next, we are going to move one end of our resistor from pin 30 over to the negative. Remember, all grounds are common, so it doesn't matter which one we use. Next, we're going to take our button and we're going to insert it into our breadboard. We're now going to take a jumper cable and put one end into row 16, which is number 6 on our GPIO header, and the other end into 28. The last instruction is to take our resistor and put one end in row 30 and the other end in our 3.3 volt positive. Now we create the code for our program. First we open Terminal and then gedit. Save this file right away as buttonpress.py in your tasks folder and hit save. The big difference in this program is that we are setting our GPIO pin 6 to receive an input. As with the other code, we import our Raspberry Pi GPIO as GPIO and import time. Next, we want to set our GPIO set warnings to false and print setting up GPIO and set our mode of our GPIO to BCM. The next block that you see is quite a bit different than our output. We set our GPIO.setup pin 6 as a GPIO.in. And the next little bit is where our difference comes in. Inputs are very sensitive to change, so we need to reduce its sensitivity by using the pull-up-down module in GPIO. This allows the program to only accept input when it senses a change instead of a state. So we type pull-up-down equals GPIO.pud down. The next block also looks a little bit different. We're going to be adding a try exception block. This allows us to cleanly exit our program since there's no logical end. So we type try, and then we have a loop while true, so it's going to run all the time. If the GPIO input 6 equals true, we're going to print button pressed. Then we're going to give it a time sleep of 0.2 milliseconds. This allows it to register the change between a button press and the button not being pressed. Underneath that is our exception to our try, which is a keyboard interrupt. So we can hit Control-C and exit our program. When we do hit Control-C, the GPIO cleanup will come into effect. Save what you have done. Now that we have our program set up, we can run it. Go back into Terminal and change the directory into the folder where our program is saved. Type sudo python buttonpress.py and hit enter. Now you can push the button and see what happens. Every time you press the button, it should print something onto the screen. Now that you know that the Pi can influence the outside world, this is just the beginning. You are controlling a simple circuit, which means that you can control anything that hooks up to a simple circuit. Relays to turn off lights, motors to make movable objects or even robots, door locks, security systems, home automation. You can even accept input from switches, motion sensors, and remote controls. The options for using the Raspberry Pi go as far as being able to control your Pi over the internet with a smartphone or even your computer. These can even output to those devices. This takes a lot of work and a lot of learning, but it could be an option for you in your inquiry projects. The only limit is your willingness to tinker and learn. So until next time, keep making.